Okay, so this is going to be a quick video comparing the line noise introduced by these two DC electronic loads. Maybe if you're doing conducted emissions testing and you wanted to see what these loads might do to your tests. The first one is this Kunkin KP182, and then the second one I'm going to be comparing against is this BK Precision 8500. Now to do these tests, what I'm going to do is I'm going to take the positive line and pass it through this Tekbox current monitoring probe and connect it up to the positive line of the load, and the negative line is just going to, of course, ground on the power supply. And I also have the power supply connected to this ground plane. I honestly don't know if it matters, but just hooked it up just in case. Okay, to set up a baseline, I'm gonna first just measure this power resistor. It won't introduce any noise into the lines. And when I turn on the power supply, this little power supply can do about, let's say, like 10 to 15 watts. So the voltage is 12 volts and current is also maxed out at around 1.2 amps. And that's making this little power resistor pretty hot right now, but that's what I'm going to be measuring. Okay, so the way these current probes work is they're effectively measuring the current going through this wire, turning that into a voltage that's going into an oscilloscope, or you could put it into a spectrum analyzer. But then you have to convert this voltage to current. And the way the probe works is it has what they call a transfer impedance. So if you imagine you get a certain voltage on your oscilloscope, or maybe a dB microvolts in your spectrum analyzer, you would take that voltage, divide by this impedance in ohms, that would give you the current. And since this is in dBs, the instructions talk about subtracting this transfer impedance, which is the same thing as dividing if you're doing it in non-dBs. And the important thing here is that these probes pretty much have a response, right? They basically ramp up and they kind of level off at around, let's say like half a megahertz or so. So anything above like a megahertz, these things, this particular probe at least, all the way up to about 250 megahertz, has a transfer impedance of roughly 18 dB ohms. So that's what I put into the oscilloscope. I basically have it converting from voltage to current, and I have an external gain set to 18 dB ohms. So this is, it'll give us some measure, but of course it's not accurate for really low frequencies. This would be for things like half a megahertz and above, but it'll give us a good relative comparison. Okay, so now for the first measurement with the power resistor, I'm going to turn on the power supply. And what we're measuring is pretty much 20 microamps of RMS noise in the line. That's the same as if I turn off the power supply. So that just kind of proves, I guess, that the power supply itself is not introducing significant noise into this particular experiment. Okay, so let's first measure the BK Precision. It is, let's see, we'll set the current limit to 1.1 amps and turn it on. And even with the instrument on, we're already getting some noise just by having the instrument on. Say like 29, 30 microamps of noise. That's what it looks like in the scope. And then I'm going to turn on the power supply. There we go. So we have more, I guess it looks like switching noise or whatnot. And we're now up to around 70 microamps of noise in total. So that's basically clearly more noise than the power resistor. That's the BK Precision 8500 doing that. And now we'll measure the Kunkin electronic load. I'll turn on the power supply. It's already set to have a power current limit of 1.1 amps, so we're getting around the same 13.5 watts. And with that, you can see, I'd say significantly more noise, more than double in terms of microamps RMS. Of course, you have to, a caveat of all this is that this guy doing it this way is kind of understating the noise that's at lower frequencies, because this is really like 100 and some odd kilohertz up to 250 megahertz. But if you were doing a conducted emissions test, you'd have to just keep this in mind, and I would probably, if you're careful enough to try to use ground planes and eliminate a lot of noise, you'd probably also want to use power resistors or whatnot to actually eliminate this kind of noise from your tests. All right, thanks for watching.